Hi everyone, and welcome to this video that takes you through the work solutions to Set 1 Paper 1H of the practice tests at Mountbatten School. A couple of things to say. First of all, it's a non-calculator paper, which means of course that you're not allowed to use a calculator. If you use a calculator at home on any particular question, then you're just cheating yourself because you won't be able to use a calculator in the real thing. So if there's a question that you can't do unless you use a calculator, ask me and I will help you. The second thing I would say is that these videos and the work booklets actually are there to help you do the questions. So what I really recommend you do is that if you come to a question that you can't do, you watch the video or you read the work solutions first of all without doing anything. Then you put the video to one side and then you try and do it in your booklet. That's a lot different, even though it sounds the same, to just copying it from the booklet as you go. If you do that, it's a completely different thought process. So do one thing at a time. If you come to a question that you can't do, put the booklet to one side, watch the video, and then you have a go from memory, and that's the important thing. Okay, let's move on to the first question. So we're going to work out 5.4 times 0.24. And you can see that what's happened here is the person's done an estimate first of all. So this is about 5 and this is about 0.2, and 5 times 0.2 is 1. So we're expecting an answer of that kind of size. That's a good check to do because quite often we get answers that are far too big or far too small. Now what the teacher's done here is what I would recommend you do is they've taken out the decimal points, okay, and just done 54 times 24. Okay, they've done it this way. It's the way I would do it. You can do it using the grid method. You can do it using a thing called gelosia. Any way you can do it without a calculator is fine. And you get this number, 1,296. You've now got to put the decimal point back in, and the way that I would do it is say, well, you've got two digits after the decimal point here, and 1 here, making a total of 3. So I want 3 digits after the decimal point in my answer. 1, 2, 3 is there. 1.296 is the right place for the decimal point, especially bearing in mind that I'm expecting an answer of about 1. So 1.296. In question 2, the height is measured as 72, correct to the nearest centimetre. Complete the following statement to show the range of possible values of h. So the height is not exactly 72, it's just been rounded to 72. It could be bigger than that, it could be smaller than that. And basically, when you're rounding to a certain unit, the accuracy is half of that unit either way. So basically, half of a centimetre on top of 72 centimetres or below 72 centimetres. So it could be 72.5 or 71.5, half a centimetre either side of 72. Okay. You've got a carton of orange juice, and what the teacher's done here is they've drawn in the height, and it's a depth of 8. Okay, so the volume is a cuboid. It's 6 by 10 and 8 high, so 6 times 10 times 8 is 480 cubic centimeters. Now, if you turn it over onto the side where there's 20, there's two ways of doing it. You can either say, well, the base in that case would be 20 times 6, and 20 times 6 is 120, and therefore 120 times the new height must still make that volume because you've still got 480 cubic centimeters of orange juice inside the box, and that will give you 4. Or another way of saying it is before it was 6 by 10 and now the base is going to be 6 by 20. Well, if the area is twice as big, why? Because instead of 6 times 10 it's 6 by 20. That makes the area twice as big. So if the area is twice as big and the volume is the same, the height must be half of what it used to be, and half of 8 is 4. So there's two ways of doing it. This is a simple matter of putting them in order. So you use these to write them out as actual numbers, and you get them there. You can put them in order. Now, a big tip to you is this. These were the numbers that were given to you, and these are the numbers that you have to write in order of size. Some people do this, and that's fine. I might want to do that. But then they actually write these numbers along here. Okay, these aren't the numbers that were given to you. These are. Okay, so use these to put these in order. Now we're going to translate p by a vector 5 minus 2. Translate is just a flash mathematical word for a slide. We don't turn it, we don't flip it, we just slide it along. And basically this vector is saying slide it along 5 to the right and 2 down. Okay, so choose a corner. This one here is fine. 1, 2, 3, 4, 5 and 2 down. 1, 2. Make sure you don't go 1, 2, 3, 4, 5. No, move. Move 1, move 2, move 3, move 4, move 5, and then down. 1, 2. Okay, so this point has moved to here, and every point would move the same amount. So the new shape is going to be drawn here. Then you're going to have to describe fully the single transformation that maps A onto shape B. Okay, so first of all, you've got a rotation, 1 mark, of 180 degrees. And you also need to put down where the center of rotation is. Basically, where would you put your pencil before you turn the piece of tracing paper? And it would be here. And if you had to find that by guesswork, then guess what? So do I often. So don't worry if you do. Okay, so rotation, 1 mark. The amount of rotation, 180 degrees, 1 mark. Center of rotation, 1 mark. Either of these, any of these, get you 1 mark. You need all 3 to get 3 marks. And if it was 90 degrees, you'd have to say 90 degrees clockwise or 90 degrees anti-clockwise. Okay, you've got to say the direction. You don't bother with 180 because clockwise or anti-clockwise would be the same. Here, you've got to simplify this expression. Now, what a lot of people do is they write this out and then they actually open up the bracket and expand and go x times x, x squared, x times 2, 2x. You don't need to. Think about what x squared divided by x would be. Yeah, x. What would be 4 squared divided by 4? 4. What would be 7 squared divided by 7? 7. Okay, so x plus 2 squared divided by x plus 2 is simply x plus 2. Here's x plus 2 squared, 2 of them multiplied together, and then we're going to divide by x plus 2. So this x plus 2 wipes out one of these x plus 2's, leaving us with just one, x plus 2. Now, now you're going to be multiplying this expression, and I really recommend what you do is you split it. This is what I do at least. I separate the numbers and the algebra, and if this algebra is different, I do it in bits. Look, number 2 times 3, 6. Then do the algebra. Okay, do the a's first. A squared times a cubed. Add the powers, a to the power of 5. B times b, b squared. So you've got 6, a to the power of 5, b squared, all multiplied together. Right? So do the number and do the algebra. Do it separately. And if the algebra is made of different letters, do those separately. Okay, Talil is going to make some concrete mix. He needs to mix cement, sand and gravel in the ratio 1 to 3 to 5 by weight. And he wants to make 180 kilograms of concrete mix. This is what he's got, okay, not what he needs. That's important that you don't get those mixed up. This is what he's actually got, and we need to work out whether it's enough to make 180 kilograms of concrete mix. Well, obviously, if you add those lot up, you can see that it's going to come to over 180, but that's not the point. Does he have the amount of each of the things he needs? Well, in every amount, there's going to be 1 part of cement, 3 parts of sand, and 5 lots of gravel. So basically, there are 9 parts. 1 plus 3 plus 5 is 9. 9 parts in any mix. 1 of them will be cement, 3 of them will be sand, and 5 of them will be gravel. So we split the 180 into the 9 parts, and that tells us that each part is 20. So each part will be 20 kilograms. So the 1 part of cement is 1 lot of 20, which is 20 kilograms. The 3 parts of sand will be 3 lots of 20, and that's 60 kilograms. The 5 parts of gravel will be 5 lots of 20, that's 100. And this is what he needs. So now you simply need to compare what he needs with what he's got. Okay, he's got 100 kilograms of gravel, that's fine. He needs 60 kilograms of sand, that's fine. He's got 85. He needs 20 kilograms of cement, but he's only got 15, so he can't make that amount of concrete. So don't forget to actually say, he does not have enough cement because he hasn't got enough, I beg your pardon, he can't make the gravel. Shall we start again? He can't make the concrete because he doesn't have enough cement. All right, it's really important that you actually answer the question, does he have enough? No. He's got enough sand and gravel, but not enough cement. He needs another 5 kilograms. Suha has a full 600ml bottle of wallpaper remover, and she's going to mix some of the wallpaper remover with water. Here's the information on the label of the bottle. So, mix 1/4 of the wallpaper remover with 4,500 milliliters of water. So, she's going to use 750 milliliters of water. How much wallpaper remover should she use? Well, if you look at this recipe here, and that's basically what it is, you're going to mix 1/4 of the wallpaper remover, and 1/4 of 600 is 150. So basically 150 milliliters of wallpaper remover get mixed with 4,500 milliliters of water. So that's the ratio, 150 to 4,500. Simplify that down and you get 1 to 30. Basically, you need 30 times as much water as you do wallpaper remover. Now she's going to use 750 milliliters of water. So there it is there. And we need to find out what the number is that's going to go there. Well, if you divide that by 30, it goes in 25. So basically, we need to multiply 30 by 25 to make 750. In that case, we need to multiply that by 25. Okay, and we get 25 milliliters. A quick double check, if you times that by 30, you'll get 750. So if she uses 750 milliliters of water, she needs 25 milliliters of wallpaper remover. This question is nice and easy as long as you take your time. So first of all, write down the class interval containing the median. Now, a lot of people are going to take this one there because they know that the median is the middle number. And the thing that makes it difficult is you've got more in some boxes or some intervals than others. These things here are what are called the class intervals. Okay, now you've only got 8 in here, but you've got 18 in here, so it makes a difference. If you add up the 8 and then the 11 to get 19 and then 28, 42, 60, okay, then you get the total number of CDs. And the median will be the middle position, which will be 30. So we need to find out which box contains the 30th. Well, here we've got 8. And now, if we add these 11, we've now added 8 and 11, 19. So we've counted 19 CDs so far. Then we have another 9 here, and that takes us up to 28. Okay, it's not until we add these 14 that we go over 30 into 42. So the 30th CD, or the 30th student, I beg your pardon, will be in here. Okay, so I think before I said about number of CDs, actually it's students, isn't it? Okay, we've got 8 students with 0 to 4 CDs, 11 students with 5 to 9 CDs, 9 students with 10 to 14. So we want to find the 30th student, and they're going to be in there, because up to that point we've only counted 28 of them. Okay, so it's 15 to 19. Here we go. To draw a frequency polygon, what you've got to imagine is using this information to draw basically a bar chart. Okay, now you can draw the bar chart if you want to. Personally, I do because it helps me to avoid making mistakes. But if you imagine from 0 to 4, then from 0 to 4, here is your bar, and it's going to be 8 high. So here is your bar, just try and picture that there. Here's your bar, and it's 8 high. Okay, you put a cross in where the middle of that bar would be. The next bar is going to go from 5 to 9. Don't join up the 4 to the 5. So we've got a space here. Next one's going to be 5 to 9. So, and that's going to be 11 high. So here's 11, and it goes from 5 to 9. So the halfway point is there. Okay, and basically, once you've got these 1, 2, 3, 4, 5 bars, you plot the midpoint, and then you join them up. Okay. Now, I can see a mistake here. I've just noticed this with this particular teacher, I think, because we've got 17 here. That should be 22, and this person's put a cross there at 24. I was alerted to it because I can see that these crosses aren't evenly spaced. This gap and this gap and this gap is not the same as this gap. So the person who did these answers has made a slight mistake. It should be at 22. So 21, 22, and the cross should be there. Okay, so that's really why I recommend you draw in the bar chart first of all, and then put the halfway point on each bar. Okay, you can do it without the bars, but as you can see, it's easy to make a mistake. So the cross should actually be there. One tip to you: do not, definitely, unless you want to lose some marks, join that down to the bottom, and in the same way, do not join that down to here. Do not do that. Okay, just this line just floats in the air. Okay, and that's all you've got to do. Okay, let's just see if there's any more questions here. No, there aren't. Question 10, make Q the subject of the formula. So basically what we've got to do is we've got to get Q on one side of the equal sign and everything else on the other. Okay, so the first thing to do is to get rid of this bracket so we can break out and get the P out of here. So 5 times Q gives me 5Q, and 5 times P gives me 5P. Okay, and the second thing I've got to do now is get rid of this and take this to the other side so that Q is all on its own, and I put the P's in one place. So I take 5P from either side of the equation, or you can either think of that as that 5P coming over to here and becoming a minus 5P. Either way, my next line is this. The next step is to tidy this up. 8P take 5P is 3P. So I get 5Q is 4 plus 3P. And finally, I need to divide all of this by 5 to give me just Q on its own. Now there's several different steps to this, as you can see, and I've got 3 marks. So don't just do nothing. Have a go at doing what you can. Any step that is right, for example, getting rid of this bracket, that might get you a mark. Taking this 5P over to here, that might get you a mark. So do what you can. Question 11. Expand and simplify. That's just a simple matter of multiplying everything in this bracket by everything in this. So x times x gives you x squared, minus 3 times x gives you minus 3x. X times 5 gives you 5x, minus 3 times 5 gives you minus 15. And finally, put the x's together, so minus 3x, add 5x is 2x. 2 lovely, easy marks. Now you've got to solve this, which means you have to factorize it. Means you've got to break it into 2 brackets. And we're looking for 2 numbers that are going to multiply together to make minus 9. Now, if 2 numbers multiply together to make minus 9, one must be negative and one must be positive. Because if they were both positive or both negative, it'd make a positive answer. And you can see that they've added together to make plus 8. So I've got 2 numbers that are going to multiply together. One's going to be positive and one's going to be negative, and the biggest out of the 2 is the positive number. Okay, so here we go. Minus 1 and 9 is what we're looking for, because minus 1 multiplied by 9 gives me minus 9, and minus 1 add plus 9 gives me plus 8. Okay, so these are the 2 brackets. Okay, you can have them run the other way around, but the minus must be with the 1 and the plus must be with the 9. And then you just say, okay, I've got 2 things here that are multiplied together to make 0, so one of these must be 0. Either x minus 1 is 0, and that means that x must be 1, or x plus 9 is 0, which means that x is minus 9. So here are my 2 answers. Solve the inequality. Well, you just solve that like you would an equation, so just imagine that's an equal sign. So the first thing to do is take t from both sides. Take t from there, it's gone. Take t from there, you've got 2t. And take 1 from either side, take 1 from there, and take 1 from there. Now you've got 11. So 2t must be less than 11. And that means that t must be less than 5.5. And if t is a whole number, the biggest possible value that could be would be, well, it's got to be less than 5.5, and it's got to be a whole number, so it's got to be 5. Okay, now this is one of these questions that actually isn't as difficult as it looks, and I really recommend you put the information that they give you onto the table and help you work it out. So the distance from Fulbeck to Ganby is 10 miles, and then from Ganby to Horton is 18 miles. And she's going to drive from Fulbeck to Ganby, and then she's going to drive from Ganby to Horton. And she's going to leave here at 10 o'clock. And she drives from Fulbeck to Ganby an average speed of 40 miles per hour. Now, if she's driving at 40 miles per hour, that means she's going to travel 40 miles in every hour. So in that case, she's going to take a quarter of an hour to do 10 miles. Okay, if you think about it, if you're doing 40 miles an hour, that's 10 miles every 15 minutes. Or you can say that's a quarter of that, so she'll do it in a quarter of an hour. Either way, she's going to be at Ganby for 10:15. Now she wants to get to Horton at 10:35 or by 10:35, and it's going to be an 18-mile journey. So how long will that journey take? Answer: 20 minutes. Well, if it takes 20 minutes to do an 18-mile journey, then if you do 18 miles every 20 minutes, then in 60 minutes you'll do 54 miles, and so therefore you'll be doing 54 miles per hour. Okay. Okay, in question 14, we've got a proportional question. These questions, as I said to you before, they're so similar. Once you've got them nailed, you've got guaranteed marks. So it says m is directly proportional to L cubed. When L is 2, m is 160. Find the value of m when L is 3. So here you've got those three parts I've been telling you about. First of all, a statement that tells you what the relationship is between these two letters. Second bit, it tells you what L is and what m is at the same time. Okay, and then it asks you to work out what m is when L is 3. So remember those steps. M is proportional to L cubed. Okay, so then you write m is equal to some amount of, which we use a k times L cubed. Now to find k, you use the numbers that they give you. So we know that when L is 2, m is 160. So 160 for m equals k times 2 for L cubed. And 2 cubed is 8. So 160 is k times 8. So to find k, we divide 160 by 8 and we get 20. So now we know exactly what the connection is between those two letters. We know that m is equal to 20 L cubed. It used to be k, and we just worked out what k is 20. So m is 20 L cubed. Okay, so if L was 3, m would be 20 times 3 cubed. 3 cubed is 27. 20 times 27, 240. The incomplete histogram and table gives some information about the distances some teachers travel to school. Use the information in the histogram to complete the frequency table. Now what I'm going to do is I'm just going to flip over to, hopefully, Mr. Walters' example, because I think he did that a little bit better, and I like the way he did that. Okay, so basically I'm just going to make this a little bit smaller. Yeah, okay, here we go. So same question. Now what you've got to understand with a histogram is that these intervals are different, okay, and it's the area inside that is the frequency. So what we're going to do is we're going to first of all draw two more columns onto the end of the table that they give you. And the first one is called the class width, and that's basically the width of the bar that they've given you. So the first one goes from 0 to 5, so it's 5 wide. Next one goes from 5 to 10, so that's 5 wide. Next one goes from 10 to 20, and that's 10 wide. You get the idea. These last ones here, okay, this goes from 20 to 40, that's 20 wide, and this one goes from 40 to 60, so that's 20 wide. Okay, now the next column we put on here is called the frequency density, and basically that is the height of the bar. If you see here, this particular bar has got a frequency of 15. The class width is 5, and so the frequency density is 3, because 15 divided by 3 is 5, or 15 divided by 5 is 3. Basically, these two numbers here have to multiply together to make the frequency, because what I said to you before is true, and that is it's the area of the bar, not the height of the bar, the area of the bar that is the frequency. So it's 5 wide, it needs to be 3 high to make the 15. In the same way, this one here is 5 wide, and you can see that it's 4 high to make 5 times 4, 20. Okay, now this one has got a width of 10, and you can read off from here that it's 2.6 high, and so therefore 10 times 2.6 is 26. If you look at this one here, it's 0.8 high, so the height is 0.8, so 0.8 goes here, and it's 20 wide. 20 times 0.8 is 16. Okay, if you look at this one, the frequency is 10. Okay, so it needs to have an area of 10, and it's 20 wide, and therefore 20 times 0.5 makes the 10. So the 0.5 is the height of the bar that we need to draw in. Okay, I'm now just going to flip, if I can, back to, yeah, great. Okay, same answers, but I think Mr. Waters did it in a clearer way, or the way that is closer to the way that I would do it. Okay, question 16. Write down the value of 49 to the power of a half, or anything to the power of a half is just square rooted, so it's plus or minus 7. Okay, write 45 in the form k times root 5, where k is an integer. So basically what you do is you look at this number and you try to write it as two numbers multiplied together, where one is a square number. And if there's two ways of doing that, choose the way where the square number is the biggest. Now 45 is 9 times 5. Okay, yes, I know 45 is 3 times 15 as well, but neither of those are prime numbers. So I've chosen this way because 9 is a square number. Okay, and the reason that is because of the next bit. If you've got two numbers that are being multiplied together and you're square rooting it, you can split them apart as individual square roots. Okay, so the square root of 9 times 5 is the same thing as the square root of 9 times the square root of 5. And the reason I did that is because this bit, I can find the square root of it because 9 is a square number. That's why I did it that way. And the square root of 9 is 3. So I can write this as 3 root 5. Okay, and that's what I needed to do. Something in the form of k root 5, and that's what I've done here. Here, you've got to prove algebraically that x can be written as 1 over 22. Now, we've got this repeating decimal, okay, that goes 0.0454545. We've got to get the decimal part exactly the same. Now, I can see what's gone on here, but it's not particularly clear to me, so I'm going to just flick back one more time, back to the way that Mr. Waters did this particular question, okay, which I think is a bit clearer. Okay, so we've got x is 0.045545. So the first thing is to multiply it by 10, okay, to get 0.454545. Now, if we multiply that by 100 on top of that, or by 1,000, we get 45.454545. Let me just pause for one more time. Here's my original decimal, and I'm going to multiply it by 10, and it gets me that. Okay, and that's a decimal that's going to repeat 4545 forever. If I multiply this by a further 10, I'll have that. And if I multiply that by a further 10, I'll have that. Now these are the two that I'm interested in. And the reason that is because they've got exactly the same decimal part. 454545, 454545. So that's what I'm looking for, the same decimal part. If I take this away from this, the decimal part here will take this decimal part away. Okay, and I'll just get 45. Okay, that's why I do it. Now that was 10 lots of x, and that was 1,000 lots of x, so when I take it away, it will be 990 lots of x, making 45. And now I can see that x is 45 divided by 990, and I can now just cancel that down to 1 over 22. Okay. Now, question 18, I like the way Mrs. Boy Smith has done this question. It's enlarged by the shaded shape by a scale factor of minus 1.5 centre 0.4. So here's a centre of 0.4, and you need to draw lines from that centre of enlargement, that's what it's called, through the corners of the original shape. Now, if it's a scale factor of minus 1.5, rather than draw the line further in this direction, I draw it in opposite direction. So what I mean by that is this. Whatever that length is, this length is 1.5 times as much. Okay? Whatever this length is 1.5 times as much, but in the opposite direction. It's the negative that makes it in the opposite direction. Alright, so if it was just scale factor 1.5, I'd make this 1.5 times longer in this direction, in the same direction. Okay? Or scale factor 2, make it twice as long in the same direction. Negative 2 would be twice as long in the opposite direction. So it's a negative sign that gives me the direction, plus in the same direction, minus in the opposite direction. And the number is how much times I make it bigger. Okay, so each of these corners is made, or these distances are made 1.5 times longer in the opposite direction. Okay, so a way of thinking about it is this line goes through the diagonal of two squares. 1, 2, so in the opposite direction, 1, 2, 3, 1.5 times as much. And you can see that she's clearly labelled the corners with the letters, okay, and just put a little dash by it to signify that it's the new shape. And then she just draws it up, and that's what you get. Okay, you can see that this triangle is 1.5 times bigger than this one. Okay, because that is 2 squares, and 1.5 lots of 2 is 3. 1, 2, 3, and the same for the other shapes, other sides rather. But the negative part has flipped it upside down. Okay. 19. There are 3 different types of sandwiches on a shelf. Now I'm going to flick back to Mr. Waters' answer. So let me just double check there. I'm going to go to here. Okay, and just click on to his way of doing it. Okay, just a little bit clearer. Now, let's just first of all understand what we've got here. We've got this tree diagram, and it's a really good way of setting out all the different things that can happen. So let's just first of all take some time to understand what we're doing here. There are 4 egg sandwiches, 5 cheese sandwiches, and 2 ham sandwiches, and he's going to take 2 of them at random. So first of all, it's out of 11, and we draw a tree with 3 branches because he could have an egg sandwich, a cheese sandwich, or a ham sandwich, and we label it E, C, H for egg, cheese, and ham. And here we put the probabilities of getting each of those sandwiches. 4 out of 11, because there's 11 sandwiches and 4 are egg. 5 out of the 11 sandwiches are cheese, and 2 out of the 11 sandwiches are ham. So that's the first sandwich. And after that we take a third sandwich, I beg your pardon, a second sandwich. And once again, they could be egg, cheese, or ham. Now the thing that makes this a little bit more tricky is the fact that the probabilities change. Because if the first sandwich that we took out was an egg sandwich, then now there are only 3 egg sandwiches left. There's still 10 in the bag, or the box, or whatever they're kept in. Okay, but if the first sandwich was an egg, now there's only 3 out of 10 that are egg. There's still 5 cheese because the egg was chosen on the first go, and there's still 2 ham, but it's out of 10. So everything on this second go is out of 10 because we've already taken a sandwich. Okay, here the probability of egg is 4 out of 10 because the first sandwich was cheese, and therefore there's going to be 1 less cheese, so that's 4 out of 10. So you've just got to concentrate, okay, when you set this out, just not rush it. Okay, and once again here, this is the probability that the first sandwich is ham. Well, in that case, if the first sandwich was ham, only 1 ham out of 10 will be ham, or 1 sandwich out of 10 will be ham on the second go. Okay, now you can find the probability of any combination simply by multiplying the 2 probabilities together. So for example, if I wanted to find out the probability of getting 2 egg sandwiches, it would be this probability multiplied by this probability, 4 times 3, 12, 11 times 10, 110. Okay, that's the way it works. Now it says, work out the probability that she takes 2 different types of sandwiches. Now, it sounds first of all like that's got to be a lot of work, because how could that happen? It could be egg and cheese, egg and ham, cheese and egg, cheese and ham, ham and egg, ham and cheese. Okay, that's a lot of multiplication to do. Here's a much quicker way. If you think about it, the sandwiches that she chooses are either going to be different or they're going to be the same. So if you find the probability that the egg sandwiches are the same and take that away from one, what's left is the probability that they'll be different. And that's a quicker way of doing it. So the probability that they're both egg is this probability times this. 4 times 3, 11 times 110. Here you go here. The probability that they're both cheese is this times this. Okay, cheese and cheese. Multiply the probability together. The probability is both ham is ham times ham, 2/11 times 1 over 10. This gives me 12 over 110. This gives me 20 over 110. And this gives me 2 over 110. And this should actually be in a big bracket. Okay, this 34 over 110 is made from these being added together. And this is the probability that they are the same. So if you take it away from 1, then you get 76 over 110 that they're different. Okay, now once again you've got 5 marks. There's a lot of work to do for this question. Okay, so anything you do is going to get some marks. There's a lot of marks, there's a lot of things to do, but do something and get some of the marks. Okay, I'm just going to head back to, hopefully, Mrs. Boyce Smith's one. Okay, in the diagram, A is at the point -2, 0 here, B is at the point 0, 4, and C is the point 5, -1. Find the equation of the line that passes through C and is perpendicular to AB. Okay, well, first of all, we've got to know one thing, and that is that 2 lines that are at right angles to each other, that means perpendicular, they're going to have a gradient that is where one is the other one underneath one and negative. For example, if one is 4, the other one will be -1/4. If one is 2, the other one will be -1/2. So when one is positive, the other one is negative, and it's upside down underneath one. Okay, basically another way of saying it is when you multiply the 2 gradients together, it makes -1. Okay, now first of all we need to find out what the gradient of this line is. Well, as we go from here to here, we go along 2 and we go up 4, and the gradient is the change in the amount of y divided by the change in the amount of x. So it's 4 divided by 2, which is 2. So the gradient of this line is 2. And you can see that the teacher's now said it's 2x plus 4 because it passes through 4. Didn't actually need that bit, but she's done it anyhow. The important thing is it's got a gradient of 2. Now the line that's perpendicular to that will be like that. So you can see it's sloping downwards, which means it's negative. And it's going to have a smaller gradient sloping down than this one that slopes up. Okay, and that's because it has a gradient of -1/2, because that's the connection between 2 lines that are perpendicular. If this one is 2, the other one will be negative, and it'll be 1/2. All right, so if that was 4, it would be 1/4, and it would be negative. So that tells us that the gradient of this line is going to be -1/2, and so the equation of the line is going to be y equals -1/2x plus c, because that gradient is always the x number. Just like up here, this line's got a gradient of 2, and the equation of the line is y equals 2x plus 4. This number is the gradient number. Okay, so we need to work out what that c is. Okay, now the way we would do that is we know that the line passes through this point here. It passes through 5 minus 1. And that means that when x is 5, y is -1. So we put in these numbers into this equation. We put in -1 for y, and we put in 5 for x. And when we work it out, we get -1 is equal to -1/2 times 5 is -2.5 plus C. So the C must be 1.5, because if you add 1.5 to minus 2.5, you get minus 1. And so the equation of the line is y equals minus a half x plus 1.5. Now once again, a 4-mark question. If you do nothing, you get nothing. If you could work out the gradient of the original line, that would be something. If you could use that to work out the gradient of the new line, that would get you some marks. This bit is probably the most difficult part, okay? But you can still pick up marks for doing this part here and this part here. So once again, do what you can do. 21 is not so easy, I beg your pardon, not so difficult as it would seem. Once you know that x squared plus y squared equals 9 is basically the equation of a circle with a radius of 3. So you just use a compass to draw a circle with radius 3. Okay. Then you draw a line where x plus y equals 1. So if x was 0, x is 1 and y is 0, there's a point. If x is 0 and y is 1, there's a point. If they were both 0.5, there's a point. So that gives you 3 points, and you can continue with that and just draw the line round. Okay, so here's my line, x plus y equals 1. And here is the circle that has an equation, x squared plus y squared equals 9. And it's just a simple matter of reading off where they cross. Okay, so read there, what's the x number, what's the y number. Here, what's the x number, or beg your pardon, what's the y number, and what's the x number. Okay, and just reading that off. Okay, two solid shapes, A and B, are mathematically similar. The base of shape A is a circle with a radius of 4, and the base of shape B is a circle with radius 8. The surface shape area of shape A is 80. Now, what's really important, you understand what mathematically similar means. Mathematically similar means that one shape is an enlargement of the other. All right? So, for example, what you can see here is the radius of this circle is twice as big as the radius of this circle. And that then tells you that every single measurement here is twice as big as the corresponding measurement here. So that is twice as big as that. That, if you knew it, is twice as big as that. Okay, the height here, okay, is twice as big in this shape here. Every dimension here is twice as big as every dimension here. Now, if the lengths are twice as big, then the area will be 4 times as big. All right, if you just think, we can cover this later on, but if you think about a square, think about a 1 by 1 square, make it twice as big, it's now a 2 by 2 square. The 1 by 1 square has got an area of 1, but the 2 by 2 square has got an area of 4. So you can see that the area is 4 times bigger, even though the lengths are 2 times bigger. And that's the same on any shape. Okay, even true of you. If you became twice as big in every direction, you'd need 4 times as much skin. So, because you know the lengths are twice as big here as they are here, all the areas here will be 4 times bigger than the areas here. So if this has got a surface area of 80, then this will have a surface area of 4 times 80, 320. Now, volume continues in a similar way. If you imagine a 1 by 1 by 1 cube, its volume is 1. But a 2 by 2 by 2 cube has got a volume of 8. So the volume has gone up by 2 cubed, 8. So even though the lengths are twice as big, the areas are 4 times as big, 2 squared, and the volume is 8 times as big, 2 cubed. So basically, this has got a volume 8 times bigger than this. So if this has a volume of 600, then we need to divide that by 8 here to get 75, and that will be the volume of that shape. Okay. Lastly, okay, we're going to look at this shape here, the last question on the paper, and we've got to prove that this shape here is a rectangle. Now you can see that the person's drawn it in. It doesn't look like a rectangle. It doesn't need to look like a rectangle. We've got to prove that it is. Okay. Now, the first thing to do is to say that we need to know about tangents. And now when tangents meet at a point, so if I had a point there and I draw it to make a tangent to this circle, here and here, it's a mathematical fact, you may not have done this yet, that this length is the same as this length. Okay, that's a mathematical fact. So that is the same as that. Now we can also see that this is a tangent to this circle as well. And this is a tangent to this circle. So these two are also the same. Okay. Now, so if that is the same as that, and this is the same as this, then these two are the same thing. And it tells us also that EC is the same as EA. It tells us somewhere, it tells us, where does it tell us? E is the intersection of DB and AC. Okay, so intersection. Okay, so that means that AE and EC are the same. That was given to us. So basically, that and that and that and that are the same. So if two diagonals bisect each other and they are the same length, okay, then the shape they make is a rectangle, and that proves it. Just be careful. If you think about a parallelogram, the bisectors, the diagonals bisect themselves there, but they're not the same length. All right, if you just imagine a parallelogram, think about joining the corners up. One diagonal is shorter than the other one. Okay, one's longer, but they still cut each other in half. All right, but here we've got a situation where the diagonals cut each other in half, and they're the same length, and that means then that the shape that they make is a rectangle. Okay, I hope that was helpful to you. If it wasn't, then let me know. If I can go over any particular question again with you personally, happy to do that. And I hope it helps you get better marks on the booklets to come. Cheers, everyone. Thank you.